Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss one of the important topics of the subject fluid mechanics and fluid machine, and the topic is hydraulic turbines and hydraulic pumps. So basically, first of all, I will discuss what is hydraulic turbines and what is hydraulic pump. Afterward, in subsequent slide, I will discuss in detail the construction and working of hydraulic turbines and pumps. So basically, hydraulic turbine is the hydraulic machines which convert the hydraulic energy into mechanical energy. So we can say that basically this is hydraulic turbine which convert this um, hydraulic energy available at the inlet of hydraulic turbine into mechanical energy, and further this mechanical energy is utilizes by this generator to produce the electricity. Then what is the classification of hydraulic turbine? So basically, according to the type of energy at inlet, the hydraulic turbine is classified into impulse turbine and reaction turbine. What is impulse turbine? The turbine, those type of turbines in which at the inlet of the turbine there is only kinetic energy, and this kinetic energy is further converted into mechanical energy with the help of this impulse turbine is called impulse turbine. The example of these turbines are Pelton wheel turbines. And what is reaction turbine? If at the inlet of the turbine there is pressure energy as well as kinetic energy, then this turbine is called reaction turbine. The example of reaction turbines are Francis turbine and Kaplan turbine. Then second classification is according to the direction of flow through runner. So this turbine is called tangential flow turbine, radial flow turbine, axial flow turbine and mixed flow turbine. The example of tangential flow turbine is Pelton wheel turbine. Radial flow turbine is called Francis turbine. Then axial flow turbine is called Kaplan turbine, and mixed flow turbine is the example of mixed flow turbine is modern Francis. Then according to the head at inlet of turbine, the turbines are classified as high head turbine, medium head turbine and low head turbine. If the example of high head turbine means Pelton wheel turbine, medium head turbine, Francis turbine, the example of low head turbine is Kaplan turbine. Then according to the specific speed of the turbine, turbines are classified as low specific speed turbine, medium specific speed turbine and high specific speed turbines. Then now I will discuss the construction and working of Pelton wheel turbine. So basically Pelton wheel turbine, also known as Pelton turbine, is a type of impulse turbine used for high head, low flow hydropower applications. It converts the energy of high speed water jets into the mechanical energy, which can then be converted into electricity. Below is an explanation of its working with a neat sketch. So this is the velocity triangle of Pelton wheel turbine. So this is inlet velocity triangle and this is outlet velocity triangle of this Pelton wheel turbine. So this is the schematic representation of Pelton wheel turbine. The components of Pelton wheel turbines are penstock. This one is penstock. This is spear. Then this is nozzle. This is runner. This is bucket, and this is brake nozzle. This is casing. What are the key components of Pelton wheel turbine? So the first one is nozzle and flow regulator. It directs high speed water jet at the runner buckets. Then second one is runner with buckets convert jet energy into rotational motion. Then third component is casing. It protects the turbine and contains splashing water. Then brake nozzle stop the runner when needed by applying a counter jet. So these are the key components of Pelton wheel turbine. Now I will discuss the working of Pelton wheel turbine. The first is water supply. High pressure water from reservoir या penstock is directed through a nozzle. The nozzle converts the pressure energy of water into high velocity jets. Then the water jet strikes the specially designed split buckets mounted on the periphery of the runner. The bucket is split into two halves with a central ridge, allowing the jet to be deflected smoothly without any splash. Then the water jet imparts its momentum to the buckets, causing the runner to rotate. The deflection of water through 160 to 170 degree ensures maximum energy transfer. Then the runner is connected to a shaft that transfers mechanical energy to a generator for electricity production. And finally, the water after transferring its energy is discharged at atmospheric pressure into the tail race. So these are the this is the complete working of a Pelton turbine. Now I will discuss construction and working of Francis turbine. So basically, Francis turbine is a reaction turbine widely used in hydroelectric power plants for medium to high heads and large flow rates. It operates by converting both pressure and kinetic energy of water into mechanical energy to drive the generator. This is the schematic representation of Francis turbine. This is water comes from penstock. This is stationary vanes. This one is stationary vanes. This is scroll casing. This is called scroll casing. This is runner. And this is draft tube. So this is schematic representation of this reaction turbine. What are the key components? So first one is scroll या volute casing. The water enters through a scroll casing which distribute water uniformly around the turbine. Then guide vanes या stationary and adjustable vanes. These guide vanes control the flow direction and regulate the water flow rate entering the runner. Then third component is runner. Basically, runner consists of a series of curved blades. Water flows through these blades, transferring its energy to the runner and causing it to rotate. Then draft tube. The draft tube is a pipe of gradually increasing diameter. It reduces the velocity of the water existing in the turbine and converts kinetic energy into pressure energy, ensuring efficient energy transfer. Then shaft. The shaft transmits the rotational motion of the runner to the generator for electricity production. So these are the key components of Francis turbine. Then what is working? Firstly, water from the reservoir is directly into the turbine through a penstock at high pressure. Then the scroll casing distributes water uniformly around the turbine. Then guide vanes adjust the flow and direct water onto the runner blades at an appropriate angle. After then, water strikes the runner blades, transferring both kinetic and pressure energy. This causes the runner to rotate, driving the shaft connected to a generator. Finally, water leaves the runner enters the draft tube, where its velocity is further reduced and it is discharged into the tail race. This is the layout of hydropower plant. So basically this is head race label, this is tail race label, this is dam या reservoir where water is stored, and this is penstock. This is the penstock. Here this is nozzle, this is our turbine. It may be impulse turbine or reaction turbine. So this is the simple layout of hydropower plant. Then what is hydraulic pumps? So basically hydraulic pump is a machine, hydraulic machines, which convert the mechanical energy into hydraulic energy. Means hydraulic pumps convert mechanical energy into hydraulic energy, whereas hydraulic turbines converts hydraulic energy into mechanical energy. These are the difference between hydraulic pumps and hydraulic turbines. Then what is classification of hydraulic pumps? So based on operating principle, the pumps are classified into positive displacement pump. Examples: reciprocating pumps, gear pumps and piston pumps are the example of positive displacement pump. Then non-positive displacement pump, examples centrifugal pump. Then based on fluid displacement, pumps are classified as fixed displacement pump, variable displacement pump, and based on direction of flow, this is unidirectional pump or bidirectional pump. So these are the classification of hydraulic pumps. Then what is centrifugal pump, its construction and its working principle? So this is the schematic representation of centrifugal pump. This is impeller, this is casing, this one is casing, this is suction pipe, this is sump, foot valve and strainer, eye of pump, this one, delivery pipe. And so basically a centrifugal pump primarily consists of the following components: casing, volute shaped enclosure that houses the impeller and directs fluid to the delivery pipe. Then impeller, it rotating component with blades that imparts kinetic energy to the fluid. Then suction pipe connects the fluid source to the impeller eye. Then delivery pipe carries fluid from the pump to the outlet. Then foot valve, a one-way valve at the suction pipes end that allows fluid in but prevents backflow, maintaining priming. And the last one is strainer, a mesh attached to the foot valve to block debris and protect the pump from clogging. Then what is the working of centrifugal pump? So when the impeller rotates, imparts kinetic energy to the fluid, causing it to move outward due to centrifugal force. This motion reduces the pressure at the impeller eye, allowing fluid to flow into the pump from the suction pipe. After then, the fluid then flows radially outward through the impeller vanes, gaining velocity and pressure. In the volute casing, the high velocity fluid is converted into pressure energy and the fluid is discharged through the delivery pipe. This process ensures a continuous flow of. So this is the working of centrifugal pump. Now I will discuss reciprocating pump. So this is the schematic representation of reciprocating pump. This is cylinder, this is piston, this is connecting rod, this is crank, this is suction pipe, sump label, suction valve, this is delivery pipe and delivery valve. So a reciprocating pump mainly consists of the following components. First one is cylinder, a strong hollow tube in which the piston moves back and forth. Then piston moves inside the cylinder to create suction and delivery. Then crank and connecting rod converts rotary motion into reciprocating motion. Then suction valve allows fluid to enter the cylinder during suction stroke. It is a one-way valve. Then delivery valve allows fluid to exit the cylinder during delivery stroke, also a one-way valve. Then suction pipe carries fluid from the source, means sump, to the pump. Then delivery pipe carries fluid from the pump to the delivery point. This is the construction of a reciprocating pump. Then what is working behind reciprocating pump? So the whole working of reciprocating pump is divided into two stroke. First one is suction stroke and second one is delivery stroke. So during suction stroke, the crank rotates and pulls the piston away from the cylinder head towards the outer dead center. Then this increases the volume of the cylinder chamber and reduces the pressure inside it. Because of the pressure drop, the suction valve opens due to the higher atmospheric sump pressure outside. Fluid enters the cylinder from the sump or reservoir through the suction pipe and valve, and the delivery valve remains closed during this stroke. Then during the delivery stroke, the crank continues to rotate and now pushes the piston towards the cylinder head. Then this decreases the volume inside the cylinder, thereby increasing the pressure. When the pressure inside the cylinder exceeds the delivery pipe pressure, the delivery valve opens and fluid forced into the delivery pipe and sent to the desired location. Meanwhile, the suction valve closes to prevent backflow into the suction pipe. So this is about construction and working of reciprocating pump. Then what is hydraulic lift? Basically, hydraulic lift is the application of Pascal's law. Basically, it is a device used for carrying passenger or goods from one floor to another in multi-story building. Hydraulic lifts are of two types: direct acting hydraulic lift and suspended hydraulic lift. So this is the schematic representation of direct acting hydraulic lift. In this, it consists of a ram sliding in fixed cylinder as shown in figure. At the top of the sliding ram, a cage on which the person may stand or goods may be placed is fitted. The liquid under pressure flows into the fixed cylinder. This liquid exerts force on the sliding ram, which moves vertically up and thus raises the cage to the required height. And finally, the cage is moved in the downward direction by removing the liquid from the fixed cylinder. So this is the working about direct acting hydraulic lift. Then what is the working behind suspended hydraulic lift? So this is the schematic representation of suspended type hydraulic lift. Basically, it consists of a cage suspended by a wire rope, which is operated using a jigger mechanism. At the base, the jigger includes a fixed cylinder, a sliding ram, and a set of pulley blocks, one fixed and one movable. When high pressure water enters the fixed cylinder, the sliding ram moves left, pulling the movable pulley block and increasing the distance between the pulleys. This pulls the rope and lifts the cage. To lower the cage, water is released from the cylinder. The ram moves right, reducing the pulley distance and the rope length, allowing the cage to descend. So this is suspended type hydraulic lift. So in this lecture, this is all about for this lecture.